Cloud services. 10 reasons to use the cloud for your game. Cloud services are more and more necessary in the tech world, and games are not an exception. I know, right? Well, in this session, Paul Viglianzone, head of North America Business Development and Game Tech at Amazon, will run through 10 cases showing how a game developer can use cloud services to improve their game development. All right, so this session is in English. So if you want to watch it in Portuguese, just please use the right link here at our channel. Let's welcome then Paul Viglianzone, head of North America Business Development, Game Tech at Amazon. How are you, Paul?
I'm great. Hi, everybody. It's fantastic to be here today and presenting to you all.
Well, it is fantastic for us as well. So please make yourself at home. The screen is yours.
Awesome. Let me just get queued up here and make sure I'm on the right slide. Okay. Can you see me okay, the slide? All right. Great. Hi, folks. So I'm Paul Viglianzone. I'm head of business development here for Amazon Game Tech in North America. Today, I'm here to talk about why the cloud is so important for your game development and how AWS services can help you achieve your goals. I'm sorry, actually, can I interrupt? Can you see my slides all right? It seems like you're seeing the notes.
You can use it on full screen.
Yeah, I'm sorry, it's not really working for me here. How's that? Is that better?
Yeah, well...
I'm sorry, I'm having trouble with my screen sharing here.
No, it's okay, don't worry. Check it out. At the bottom of your page, you do have like a small icon. It looks like, well, a Tupperware or something like that. You should try to click that, and that will go on full screen for you.
I'm sorry for this, folks.
No, don't worry. We already had a similar issue today, so it's not only you, you know?
Okay, how's that? Is that working? You can see the screen okay now without the notes?
Well, you need to share it, and you use the full screen button.
You can see the screen, full screen?
No, not yet. But
okay.
It is, well, you can speak with our production, and while that, I'm going to say some stuff to our public, okay? Okay, that's great. Oh, yeah, it is, no, it's not like that.
Okay.
You need to click on the slideshow button. Now, that's great.
You can see it now?
Yeah, that's perfect. Thank you.
Awesome. All right, sorry about that, folks. Sorry for the delay.
No, it's okay, don't worry. The screen's yours.
Okay, great. So what I'm going to do is I'm going to jump straight into this now. So before I talk about the particular use cases I want to share, I do want to sort of explain a little bit about Amazon Game Tech. So whether you're a team of one person or 1,000, one thing that really matters, and really the only thing that really matters, is making a game that players want to play. So how you get there is really the question. And that's where we can help. So AWS Game Tech is the team at AWS that is laser focused on the gaming industry. We like to say that we're obsessed with games, and that's really the collection of all the products from across Amazon that offer solutions for every stage of game development. So Amazon Game Tech provides robust, scalable solutions for every stage in your game's lifecycle, regardless of your studio size. With AWS, Twitch, and our managed game services, we're striving to be one of the most customer-obsessed companies in the games industry. So let's jump into the first example, scale. Now, the first reason to use the cloud for your game is really capacity to scale rapidly. As every game developer is well aware, video games are a hit and miss business. We all work tirelessly to build great games, but we cannot predict if they will be successful or not. Imagine trying to forecast the required servers for a new multiplayer game when using on-prem infrastructure. If you use more than needed, you will pay for unused servers. And if you order less than needed, you're going to have to deal with disappointed players who cannot access your game during high traffic periods. This is especially magnified if you are running events in the game, which get big spikes in users for short periods of time. So the solve for this problem is to leverage the almost unlimited capacity of AWS Cloud to scale up and down as you need. AWS gives you the ability to easily add servers when you need them and then turn them off when you don't. And the biggest benefit, you only pay for what you use. So if we look at Epic Games are a great example. They run Fortnite on AWS, and they're able to handle scaling up for any in-game event as needed. Fortnite is sort of really becoming more of a platform for user engagement and in-game events like, the Travis Scott concert, which drew 27.7 million unique players and created a truly groundbreaking and hugely scaled experience. So to support this type of activity, Epic are running game servers across 26 AWS availability zones and scale up by 10x between their high peaks and their low peaks. And this is really a great example of a developer who's leveraging the AWS cloud for scale. Okay, another great example of a customer who's using AWS is Quantic Dream. So one of the things about Quantic Dream is that they wanted to really manage their remote development teams with cloud-based workstations. And we've seen a number of game developers looking to use AWS to solve for problems associated with distributed development. And this has really accelerated during the COVID-19 restrictions. So at AWS, we call this game production in the cloud, which simply means having everything from your workstations, your version control, and your build pipelines available to you and your team from the cloud at all times. So Quantic Dream are the creators of AAA interactive storytelling games like Nomasol, Indigo Prophecy, and Heavy Rain. And when COVID-19 hit Europe, long-term remote working plans suddenly became really a priority for two main reasons. One, they had recruitment goals as they expanded into PC as well as PlayStation development. And two, they really wanted to empower their artists, animators, and designers who are now working remotely in Paris. And it wasn't feasible or practical to distribute the studio's hardware amongst dozens of individual employees' homes. So they needed remote workstations to enable their teams to continue developing. So working with AWS, their solution was to build their own client and serverless backend using Amazon API Gateway, AWS Lambda, so they could facilitate connections to cloud workstations running on Amazon EC2 instances. And this setup additionally added a layer of additional security to their assets and intellectual property, which was a crucial consideration for their development. Okay, next slide. So this is a really interesting use case here. I think let's take a look at how Sony used AWS to solve a rendering challenge that they had. And that really helped them to speed up their production. So Sony's PlayStation studios, very famous. They're an award-winning group of studios who've made outstanding games like Little Big Planet, MLB The Show, God of War, an Uncharted series, among many, many others. As their creative services team prepared for a global press event, they needed to produce a lot of motion graphics. And that was at 4K 60. So this process of rendering, which brings together all the different work streams into a single sort of motion graphics artifact, like a gameplay video, is super compute intensive. So as they ramped up for their event, they found that their on-prem solution really turned into a bottleneck for production with long render times and job contention. So simply put, really too many jobs and too little time. So they were really on a tight deadline. They needed to find a solution quickly. And so their IT team decided to turn to AWS to handle their heaviest workloads in the cloud. For them, the decision was really easy because AWS offered abundant capacity and pay-as-you-go pricing. And that meant they didn't need to worry about the capital expense and the procurement times. So AWS removed their biggest constraints, capacity, cost, and time, and this flattened their risk and enabled them to get to work immediately. And so they were able to architect a solution that really achieved several really key technical requirements for them. They could define and deploy infrastructure as code. They could deliver render workers with AWS P3 G4 instances using Windows 2019 Server. And they could leverage Demline Spot integration for render workloads, as well as handle licensing in the cloud too, which was really awesome for them. So the benefit of this solution for them is they're now able to scale up and down as they need to meet any render workloads that they have. And they can basically compress their development timelines to get those render jobs done really quickly. All right, moving along. Let's look at understanding player behavior. I think this is a really great use case here. As you know, analytics and machine learning are really important both for us as an AWS game tech, but also for developers, of course, and for games. Analytics and ML really enable better understanding of player behavior. So analytics is all about really, using data to answer the big questions around, in your game around user acquisition, engagement, monetization. And we have this great game analytics pipeline that's completely flexible and tailored to your needs. If you're using, third-party analytics or attribution vendors, you can also use this pipeline to ingest data for further analysis. And there are some really creative uses of machine learning that help you to prevent fraud in your game, or run more effective QA, or even predict churn, spend, and player behavior, and making dynamic content for your players. A great example of using ML to optimize player experiences is Rovio. In the past, Rovio would put new levels into their game each week, and only then would learn and iterate the player experience over a period of like 2 to 6 weeks. And for Angry Birds Dream Blast, they took a different approach. With machine learning doing the heavy lifting to predict playability, Rovio's players get the best experience from the moment the levels are released. So Rovio is really delivering a customized game for each individual using machine learning to understand what different types of players want from the game. So the next example I want to talk about, extending upon the Rovio example, is around running game analytics, and machine learning. It's really important to ensure that you have a solid data foundation to handle any increase in query volumes from that data. So if we take Zynga as an example, because many of their games use the free-to-play model, it's critically important for them to understand how the players are interacting with the game. For example, what features are gaining most traction? Sorry about this. Where are players dropping out, and so on. This level of analysis requires a data warehouse that can handle tens of millions of monthly active users, a few terabytes of data per day, tens of billions of records, and millions of daily queries. Because Zynga's data analytics workloads have been increasingly rapidly over the past couple of years, they found that their data warehouse was really no longer able to keep up with the growth in data and query volume. So their legacy warehouse had a high maintenance overhead coupled with an 8-week limitation on data storage, severely limiting their ability to run long-term data experiments. So they had to really over-provision to account for scaling needs. And due to high maintenance costs, they found the warehouse to be relatively expensive compared with alternative solutions. So Zynga's main goal was to reduce maintenance overhead. So they were looking for a managed service. And they evaluated market offerings and found that Redshift was better on costs. They also appreciated the high compatibility with their current tech and the future roadmap features. So they embarked on this program to migrate their data warehouse to AWS. So how did it work out for them? So it worked out really well. Post-migration, they have already been able to reduce the ingestion SLA by around 30%. They improved copy performance massively, and they also improved ETL performance. So they can now scale as needed without the need to over-provision their servers. And they don't have to worry about this 8-week, they're not limited by an 8-week data storage capacity. So they can really run long-term analyses at scale. Oh, and their costs came down as well, which is awesome. Okay, moving on to back-end services. This is something that, really are the nuts and bolts for building great engagement, social features in your games. So, for example, leaderboards or player progression or social functionality, and even handling player identity and authentication. So we have multiple options for hosting your backend design, from serverless to containers, and many additional services that can be used to really enhance these in-game features like Cognito and Poly. So one example of a customer who used AWS for backend services is Coppola, and they were building this on the success of Nonstop Night 1, which notched up around 15 million player downloads in its lifetime. So in developing their new game, the studio knew how easy it had been for players to cheat in their previous title, which was client authoritative. So since players could easily manipulate their data in an offline game, the team had a lot of design restrictions and were not really able to make it as competitive as they'd liked. So they changed this with Nonstop Night 2, their second version, and by building in the logic and rules of competitive tournaments to be determined by the server and not the client itself. So rather than install and maintain databases manually, they use Amazon RDS, Amazon Aurora, or MongoDB with AWS Elastic load balancing over 2 sets of live servers and multiple development and stable servers for testing purposes. And with this setup, they were able to keep the cooperative elements of the game while also creating a competitive tournament-based gameplay that was fair and fun for players as well. And one of the biggest benefits of running the game in the cloud is the ease of speed and scaling. Now, a recent peak in the game saw triple the number of active players compared to normal, and that was all easily handled by AWS backend services. Another great example here is about simplifying development. So sometimes developers really want to make use of managed services so that they don't have to build it themselves. And that often reduces development timelines a lot. So for multiplayer games, for example, AWS GameTech has a specific service that includes game server hosting and multiplayer services like matchmaking and spot pricing. And this is called GameLift. And some of the world's most successful game companies already trust GameLift for their games, including Ubisoft, who make, obviously Watch Dogs, Assassin's Creed, excuse me. When Ubisoft was preparing to launch the sequel to Watch Dogs, they wanted to move from their existing peer-to-peer solution, which wasn't really optimal for the game sequel. So they needed a ready-to-use solution which could meet all their requirements, including being highly scalable and elastic, globally available, and with low operational costs. So additionally, a managed service would mean less overhead, both from an OpEx point of view, but also in terms of human resources. So Ubisoft moved its Storm platform and several online multiplayer games to Amazon GameLift. This has really simplified management and increased reliability and scalability for them across many titles. It also gives them capabilities to easily engage with their players to help test and iterate on their games. So, for example, the Roller Champions team integrated load testing into their CI/CD pipeline and using GameLift Fleet IQ to handle auto scaling for their services. And they also used live phase testing to verify different metrics in the game. And that way they could gain user feedback and spin up an instance of the game, verify different metrics, and then validate server stability and matchmaking times, things like that. And after a few short days of testing, they can simply close down their servers, review the data, and then run another iteration. So this is a super cost-effective way of getting really instant player feedback for their game. The next use case I want to share with you is about reducing latency. This is a really great one. Every developer cares about latency. For many games which rely on fast twitch as part of the gameplay, like shooters or sports titles, it's super important to ensure that low latency solutions are in place to ensure the integrity of the game and deliver a good user experience. So AWS has a variety of solutions which can help game devs achieve a good low latency experience from their cloud-served game. For example, AWS Global Accelerator is a networking service that sends your users traffic through Amazon Web Services global network infrastructure, improving your internet user performance by up to 60%. And on the hardware side, local zones and outposts can get developers closer to their players by reducing the geographic distance between the game and the players. So a great example of this is Riot Games, who use Outposts to deliver low latency for Valorant, which is their new team-based tactical shooter. So one of the most pervasive technical challenges in competitive shooters is what's called Peeker's advantage, which is caused by latency. Simply put, peaker's advantage rewards aggressive play because the defending player is always reacting on a delay. And because this creates unfair advantage, right, we're very eager to ensure a low latency experience for all their players. And in the past, what they did to solve for that is, they used colos as well as AWS to deploy services close to the players. But during their closed beta for Valorant, they realized that their developers would need to spin up more capacity super fast. And for that, they wanted a better, more seamless hybrid solution. So they chose Outposts and shipped them to colos in 4 cities across three countries globally to support their game release. And now Riot is really able to rapidly move production workloads to these Outposts with no changes in their server application. Because basically Outposts uses the same tooling and interface as AWS regions. Jumping ahead now. Another example of where AWS can really benefit developers is by helping to minimize management overhead for automating tasks and freeing up more time and resources for the development of the actual game. So we see a variety of customers using managed services to take overhead away from teams. For example, Huge Games, a top mobile developer, started to work with an AWS technical account manager or a TAM to better understand which AWS services could help them achieve their goals of freeing up more time for their team to work on game development. So the TAM was able to help keep them up to date on the latest services that could deliver the performance and manageability they were looking for. As part of their improvement process, Huge Games took advantage of Amazon Elastic Kubernetes Service, or Amazon EKS, which automates infrastructure patching and other management tasks. And EKS was able to lower the overhead of system maintenance, which means that Huge can dedicate more resources to what they do best, creating engaging multiplayer and social casino games. And besides enabling Huge Games to concentrate on game development, AWS is also helping the company to enrich the gaming experience of these games. And by gaining insight to do this requires analysing 1.5 billion events a day, an activity that could involve extensive platform tuning and monitoring of a big data infrastructure. However, by using the cloud data platform, Amazon EMR, Huge Games has reduced that burden. And so this really solves their problem. So my final example for today is cost savings. I know this is something that's always very important for developers. So on average, we see up to about 30% cost reductions from on-prem or colo type arrangements when developers choose AWS. Of course, this varies between customers, their usage and the types of services they use, but it is a general rough guide. At an individual customer level, we offer a variety of services which can help the customers to lower their costs. For example, AWS Cost Explorer for reporting and analysis, AWS Cost and Usage Reporting, and EC2 Reserved Instances, or RIs, which can help reduce compute costs by up to 72%. And an example of a customer who's using this is your locally based Brazilian company, Wildlife, who are benefiting from these cost optimization tools. And they began using AWS Cost Explorer, a native AWS service that enables employees to view and analyze AWS cost and usage. And this, basically this helped them save, a lot of money, basically, on their development, because they could really optimize their workload allocations and so on. Okay, that's the end of my 10 examples. I realise we're very short on time. Sorry for the delayed start there as I got the presentation ready. So I'd like to thank everyone for taking the time. I hope you enjoyed my quick overview of how AWS can benefit your game development. I don't think we have time for questions. We're running a bit late. But feel free to email me. I'm paulvig@amazon.com, and check out our website, awsamazon.com/gametech. And I hope to see you again soon.
Thank you so much, Paul. It was a pleasure to have you here with us. Thank you again.
Thank you.
See you
Thank you
next
very much.
time.
Cheers. Thanks, everybody.
Big Festival 2021, the biggest games festival in Latin America.